right, so our notes for today are going to be number 5. Make sure you put it in that top corner because we're going to actually have to add in a definition up here on the top. All right? So today our notes are on comparing and ordering rational numbers. I don't know why I wrote helpful. Because notes are helpful. Don't know why I wrote it in. All right, so today our notes are on comparing and ordering rational numbers. Now, rational numbers are not, we haven't defined that yet. All right, we define integers. Can someone remind me what's an integer? Cameron? Positive or negative, and it's important that an integer is a positive or negative whole number. All right, so rational numbers are going to be a little bit different. They can still be positive or negative. They can still be positive or negative. All right, but when we're talking about an integer, a rational number, it's a positive or negative. Now we're going to get into fractions. It's a positive, negative fraction. All right, and technically a rational number is any number that can be written as a fraction, which is also going to include a lot of our decimals, okay? So when we're talking about the decimals, a positive or negative fraction, the decimal has to end, so an ending or a terminating. We defined that 9 weeks ago. Ending decimal. And again, the technical word is terminating decimal or repeating decimal. Okay, a positive or negative fraction, ending decimal or repeating decimal. Or, so it can be a fraction, a decimal, or also, can I write whole numbers as fractions? What can I do to write the number 5 as a fraction? Anyone remember? Clear? Put it over 1. So because whole numbers can also be written as fractions, you also have whole numbers here. So is an integer also a rational number? Yes, because an integer is a whole number, which is also a rational number. Is a rational number necessarily an integer? Are all rational numbers integers? No, because rational numbers can have fractions. Can an integer be a fraction? No, but all integers are rational. Okay. So rational numbers just mean we're still going to have positives and negatives, but now we've got to add in some fractions and decimals. So something that's going to be helpful as we talk about fractions and decimals is if we can know these common fraction to decimal equivalences. All right? So we want to be able to change fractions to decimals really quickly in our head, and we can do that by memorizing some of these basic ones. All right? Guys, I can already tell you in the 7th grade, you're going to have quizzes where you have to, like this year we did quizzes on our multiplication facts, right? Well, next year they're going to be quizzing you on your fractions and making sure that you know automatically like 1/2. All right, hopefully right now in the 6th grade we know what decimal is the same as 1/2. If you don't, we're going to write that down today, and we want to make sure when we leave class today we got that in our head, okay? Because we're going to talk about 1/2 a lot. All right, so does anyone remember what is 1/2 as a decimal? Hey. 0.5. And I'm just going to put 0.5 because 1/2 doesn't have a whole number in front. It's not 0 1/2. So I'm just going to put 0.5 there. Okay. All right. So 1/2 and 0.5 are the same. All right. Some of the other ones that we might not know as well. 1/3. 1/3. 1/3 is special. Remember we said it can be an ending decimal, like 0.5 because it stops. We also said it could be a repeating decimal, right? 1/3 is where we see that repeating happening. 1/3 is the same as 0.3, but it repeats. So it's 0.333333333. Now instead of writing all those threes, we just put a line on top, a bar on top. All right, so let's think logically, because if I know what 1/3 is, so this is 1 of all the thirds. If I know what 1 is, if I want 2, what could I do to that 3 there? Add or multiply. So we just want to double it, right? This is 1/3. Well, now we have 2 of them. So since I have 2 of them, instead of having 0.3, now we're going to have 0.6 repeating. So once I know 1, can't I figure out all the others that go with it? Okay. So we're going to kind of use that trick on the rest of these. Okay, so 1/3 is 0.3 repeating. So 2/3 is 0.6 repeating. All right, 1/4. 1/4. So guys, think about like 1 whole dollar. 1 is a whole number, correct? 1 whole dollar. Now, if I split that dollar into 4 pieces, what are those 4 pieces equal to? 25 cents, right? And how would I write 25 cents? 0.25. So 1/4 is 0.25. All right, that's one that we should know. All right, now guys, you'll notice 2/4 was skipped. 2/4 was skipped. Why do you think 2/4 was skipped? What is 2/4 equal to? Brandon? 1/2. Because 2 is half of 4, isn't it? So 2/4 is equal to 1/2, which means it's equal to 0.5. What happens if I double 0.25? What do we get? 0.50, 0.50, which is the same as 0.5, which is the same as 1/2. So do all of those still work? All right, so what if I have 3/4? So again, if 1/4 is 0.25, 3/4, just triple that. What do I get, Dina? 0.75. So if you memorize just the first one of all of them, can you figure out the other ones? Yeah. Just double them and triple them. All right, 1/5. So I'm going to give you 1/5. It's 0.2. All right, so now let's think about this. 1/5 is 0.2. If I have 2 of them, 2/5, what's that going to be? Faith? 0.4. Okay, so now we have 3 of them, 3/5. What's that going to be? Cannon? 0.6. And then if I have 4 of them, what's that going to be? 0.8. Why didn't I put 5 out of 5? We can add that on there. Why would I not put 5 out of 5 on there? Yeah, because that just equals 1. 5/5 just equals 1. Okay? All right, so our tenths, guys, our tenths should be really easy. What is the first number in the decimal place? What place value is that called? The first decimal place, what is that called? Taylor? The tenths. How would I read this? 1/10. So that's the same as having a 1 in the tenths place, because this is technically 1/10 because it's in the 10th decimal place. 1/10, 1/10. 2/10 would be 0.2 because now it's 2 in the tenths place. 3/10, 0.3 because it's 3 in the tenths place. 4/10, 0.4. 5/10, 6/10, 7/10, 8/10, 9/10. And then why don't we put 10 over 10? It's equal to 1 whole. So if you want to add that on there, we can, just so that we remember that that's not really actually decimal. It's a whole number. Okay? All right. So guys, for one, Taylor, question? Sorry.
Okay, so wouldn't 5/10 be 1/2?
5/10 is 1/2. So let's look at that. 5/10, 0.5, 1/2, 0.5. So see, those matched up. Very good observation. Because half a 10 is 5. So 5/10 is 1/2. Very good. All right, so for starters, guys, just because we got some fractions and decimals in here, I don't want us freaking out. Because you're going to still basically start the exact same way. All right, so we're going to be ordering these on our notes just from least to greatest. All right, now on our homework, I got it a little bit more challenging. You're also going to have to go from greatest to least. But for right now, let's focus on just that one direction. All right, so for number one, these don't have any decimals or anything, do they? So when I'm putting numbers in order from least to greatest, we've got to remember what comes first. The negative numbers. So guys, we're just going to look at our negative numbers first. So all I'm doing is I'm just underlining the negatives. Okay, because negative, if we're talking about the least, the smallest numbers, those are going to be our negatives first. Okay. Negative numbers. All right, which of those negatives is the least amount, the least value? Cameron? Negative 24. Very good. Because remember, on our negatives, the furthest one from 0 is the furthest one from my positives, which means it's the smallest. Again, which one is closer to being better? 8 down votes, 24 down votes, 3 down votes, or 2 down votes? The worst one would be that 24 because it's the worst case. It's the furthest away from my positives. Okay? All right, so we did negative 24. What's going to be next? Gabriella?
Negative 8.
Negative 8. All right, what's going to be next? Emily? Negative 3. All right, and what's going to be next? Adriana?
Negative 2.
Negative 2. Very good. Okay, so now we've got the negatives out of the way. Now we got to do our positives. Now remember, we're going least to greatest. Out of those positive numbers, which one's the smallest? Kate? 9. Which leaves me only one left, which is 12. All right, so that's what we did yesterday. That's not too difficult, is it? There are more numbers here, but any questions about this? Okay, so now let's look at number 2. Oh, good job. No moaning and groaning. Good. Yeah, this is why I love y'all. Okay. All right, because we're looking at this. There are fractions and decimals, but are we letting that freak us out?
No.
No, because we know the first thing I got to look at is what type of number?
Negative.
The negatives. All right, we're still going to start this the same way. Let's underline our negatives. Let's focus on our negatives. Are y'all okay with that? Because even if they got fractions and decimals, what's still the smallest? Negative numbers. All right, so guys, now I'm looking at my negative numbers. Now, if you look at these whole numbers, that's like negative 8 and some more, negative 4 and some more, negative 1 and some more. Since they all have different whole numbers, we can just focus on the whole numbers. Which one's going to be the least amount? Vina? Negative 8 and 1/5, because it has the biggest whole number, which means it's the smallest negative number. Okay, so I'm going to go ahead and mark that one out. What's next, Gabriella?
4 2/3.
Negative 4 2/3. All right, so then my last negative left is negative 1 2/7. Guys, did I even have to worry about those fractions and decimals? Okay. Let's look at the next one. So, not the next one. We still got to do our positives. So now looking at my positives, I got 3.9, 2.6, and then I just have 3/4 here. Which one of those is the least? Which one of those is the smallest? Cameron? All right, so 2.6 does have the smallest whole number, but let's think about this 3/4. Is there anything in front of it? No, so if it was a decimal, it would probably say 0 point something. So like up here, 3/4 was 0.75. Guys, if it's a fraction with nothing in front of it, I don't want you to ever write this in your answer. But while you're putting them in order, if it helps you to put that there is zero whole number, you can write that in for right now. Okay, or are you going to write it in your answer? No, don't write it in your answer. It's not part of the actual number. But if that helps you, because now which one is smallest? 3, 2, or 0? The 0. Okay, so we can use that technique if it helps us out. But when I write it, am I going to write the 0? No, I'm just going to write 3/4. Okay, and then what can we have, Cameron? Then we have our 2.6. And then we have our 3.9. Okay, so if that helps you, do that. All right, now on number 3, guys, number 3 is a little bit challenging. In fact, y'all aren't going to have any this challenging. This is going to be for my advanced group. I'm going to make them do the whole thing. But we're going to simplify this a little bit for us right now. So what I want us to do, we're going to mark out this negative 2.8. So let's color that out. We're not going to use that one in here. And we are not going to use 7/8. Okay. All right, so let's think about this. That's fine. So let's think about this for a second. What numbers do we worry about first if we're going least to greatest? The negatives. I don't even care about the fractions or the decimals. I need to look at my negative numbers. Now this time when I look at my negatives, what's both of them have as a whole number? 2. Okay, so that means we're going to have to think a little bit harder, but that's okay. So my tip here is figure out how the fraction or decimal compare to 1/2. All right? Because what is half of 12? 6. So is 7/12 going to be bigger than 1/2 or smaller than 1/2? Bigger, because there are 7 of them. Half would be 6. There are 7, so this is going to be bigger. 0.4, bigger or smaller than 1/2? Smaller, because the decimal would be 0.5, and that is smaller. So here's a question. When we're talking about our negatives, to pick the least number, do I pick the smallest number or the biggest number? The biggest, because negatives are opposites, right? So to pick the least number, we're going to pick the biggest. So which one's going to go first? -2 and 7/12. So guys, even though those had the same number involved, was I still able to compare them relatively easily? All right, so by comparing them to 1/2, it's going to simplify this a little bit. So after -2 and 7/12, the other negative we have is -2.4. Okay. All right, so now we need to compare these two. 0.6, is it bigger or smaller than 1/2? Bigger. Remember, what's the decimal for 1/2? 0.5. 0.6 is...
Number 2, you did 3.9, and all the way at the end, and I was at 2.4.
All right, remember, these are positive, so these right here have to be getting bigger. On my negatives, they go in the opposite way. They get bigger going, because it's least to greatest. But on our negatives, remember, the least is actually the opposite. It's the biggest. Now we're at our positives, so we've got to go smallest to biggest for real. All right, so least to greatest, positive numbers, they work the way they sound. So again, 0.6, was it bigger or smaller than 1/2? It was bigger. What about 1/5? 1/5, is that going to be bigger or smaller than 1/2? Smaller. All right, now guys, some people want to say that this is bigger because 1/2 would be 1/2 and 5 is bigger than 2, right? But that means that I've got one piece out of 5 pieces. If I have a pie and I only cut 2 pieces out of that pie, those are going to be 2 really big pieces, right? If I have to cut the pie into 5 pieces, aren't those going to be smaller? So 1/5 is actually smaller than 1/2. Okay, also, half of 5, 1 is smaller than that. So which one am I going to put next if I'm going least to greatest? 2 and 1/5. And then we're going to do 2.6. Okay. All right, so I've just passed out our homework sheet. I want us to go ahead and take a moment and look at some of these together. So we're basically going to go through and we're going to look at each section together to make sure that we know how to set up each problem, because the directions here are really important that we read them. All right, the first part just says what we've been doing in our notes. Place the following numbers in order from least to greatest. So since we're going least first, what type of number do we look at first? The negatives. So let's underline our negatives here. Okay, so we got our negatives. What negative number is going to come first? Faith?
-8.2.
-8.2, because that has the biggest whole number, which means since it's a negative, it's technically the smallest. All right, now this is when we got to put on our thinking caps. We got to use our brain. All right, because I've got -1/2 and -2.4. All right, so which one of those negative numbers do we think is technically the bigger one? Emily, what do you think? Okay, So we see that 4. So we might be thinking, oh, that's going to be bigger because that 1/2 has a 2 in it. But remember, from our chart today, what decimal is 1/2 the same as? 0.5, right? So this negative 2.5 is really the same as negative 2.5. So now, which one of those is actually bigger?
2 and 1/2.
The negative 2 and 1/2. Very good. So next to the 8.2, I'm going to put negative 2 and 1/2. Now, guys, even if I write the decimal up here to help me compare, I've still got to write down what was given to me in the list. Are we okay with that? Okay, and then what's my last negative number we have? Negative 2.4. All right, and then all that's left is one more number, which is positive, so it is the greatest number, 0.8. Do you see how, since if I have trouble comparing them like this, I can write that decimal equivalence that was in that chart from our notes. I can just write that with the whole number, and if that makes it easier, you're welcome to use that. Okay? All right, 2 and 3 are just like what we did in our notes. I want you trying those on your own. But for right now, if we can skip down, let's look at the next section. Now, this section says to place a less than, greater than, or equal to symbol into the box to compare the rational numbers. Can someone remind me, what are these symbols called? Faith? What are these symbols called? It's part of my vocabulary. This makes me nervous. Vocabulary's on the test. Ava? Okay, so we've heard them called alligator symbols in the past. Now remember, we're using the technical word, okay? Less than and greater than is the name of both of them, but together, what are they called? Brandon? Inequalities. Remember, it's kind of like unequal. Inequalities. All right. So right here, which inequality do I need to use? 8.5. How does it compare to a negative 8.5? 8.5 is less than, greater than, or equal to negative 0.85. Dina? Greater than, because it is positive. So my Pac-Man should be going towards the positive 8.5. Okay? And that's all you're doing on these, all right? Real quick, let's look at number 8 for a second, because this one's throwing some people off. All right? How many numbers are after the decimal here?
3.
2, right? 2 numbers after the decimal here. 0 and 5, yes? How many numbers are after the decimal here? Just 1. Could I add a number to it to make it so that they match? What's that magic number we can put at the end of decimals? Ava? 0. So add a 0 when you go to compare those, okay? Our next one. All right, guys, what do you notice has changed about our directions here? Now we're going from greatest to least. So am I still going to look at my negative numbers first? No, this time we have to look at our positive numbers. Okay, so on number 10, what are my positive numbers? 0.5. Anything else? No. So I know I've got to start with 0.5. Okay, that's done. So now we're going to look at our negatives, which is all that's left. Okay, remember I'm going greatest to least. So if I'm looking at the greatest negative number, negatives are opposites, I'm actually looking at the smallest one. Okay, so out of these, which ones are going to be the smallest? Which ones am I kind of comparing? Negative 5.9 and negative 1/9. We've got to figure out of these two, which one is smaller. Okay, so remember we said compare it to 1/2. 1/9. Is that smaller than half a pie, or is it bigger than half of a pie? Smaller. That means I'm sharing that pie with 9 people. Would you rather share it, just split it in half with someone, or do you want to have to split it up amongst 9 people?
Half.
The half. That means you're getting a bigger piece. So this 1/9 is going to be smaller. And then 0.9, is it smaller or bigger than 1/2? It's bigger because, remember, the decimal of 1/2 is 0.9. 5, isn't 0.9 bigger than 0.5? Okay. So if we're going greatest to least, remember the greatest negative is actually the smallest. So we're going to put negative 5 1/9 next. All right, and then after that, we're going to have negative 5.9. So those are my two 5s. So then my least number is the biggest negative. Is that negative 7.1? Was that the biggest negative that I had? Okay. Guys, these are more challenging than what you've been doing. I fully believe that we're all capable. All right. I need us trying this out. There are some of these on our test on Friday. So we've got to practice everything we've been doing, plus our vocabulary, plus these rational numbers. All right, we're going to look at number 13. 14 is just like what we were doing. You're putting them numbers here in order from least to greatest. All right, number 13, now let's look at this. It says a box turtle hibernates in sand at negative 1 5/8 feet. A spotted turtle hibernates at negative 1 3/4 feet. Which turtle is deeper? So guys, when it's asking which turtle dug deeper, yes?
You can compare 1 3/4, make it the denominator the same thing as the other one.
Okay, so I really love what Kate just said. This is a really great idea. He said, hey, 4, isn't it really easy to change that denominator so that it matches the 8? What can I do to that 4 to make it match the 8? Times it by 2. And if I do it to the bottom, we have to do it to the top, okay? So now this spotted turtle dug down. The 1 stays the same. 3 times 2 is 6. And 4 times 2 is 8. So I get negative 1 5/8 and negative 1 6/8. So which turtle dug further down? Which turtle dug further down? Faith. The spotted turtle. So which turtle is deeper would be the spotted turtle. Because he dug 1 6/8 down, where the box turtle only dug 1 5/8 down. Okay? All right, so the rest of the homework, I want you to finish the rest of the worksheet on your